Hi and welcome to Poleshift News. Guys, as always, big thanks to those few people that have been supporting us over the last few days. Amazing efforts from some of you guys. So where are we? Over the weekend, hopefully we will have at least the magnetometers going out to the United States and Australia, east and west. We're still looking for somewhere in either North China or South Russia. Hopefully over the weekend we can do something about that. If not, we might have to change just some of the locations where we're going to put them outside of those countries, because I think we all know there is a bit of an iron curtain with regards to information coming out of those countries. It's almost frowned upon, and you could see how some of these countries would say it's almost on the level of spying. And you know, the fear has been put into these people within these countries that such a thing would be considered like that, and therefore they would never have anything to do with it. So if worse comes to worse, we're going to just have to look further afield. Okay, recently in the comment section on a few of the last videos, someone was tempting me to get into the conversation of what's really going on with our sun and how it really works. So, you know, I did ask him to tell me what his version of it was, and he provided a few links which I've seen before. And let's face it, we've seen, I'm pretty sure if you haven't, it's well worth having a look at some of the Thunderbolt projects, you know, reasoning behind the electrical universe. But to me, you know, it isn't new. I've come across the Thunderbolts project many years ago, and to me it was like, you know, okay, so what are you trying to do? Reinvent the wheel with the electrical universe? You know, I could easily go on further and say it's a magnetic universe. After all, there is the same going on with electrical and magnetical, and that's why we have the electromagnetic effects we do when we build coils and things like that. So, you know, it's nothing for me, it's nothing new. I don't want to offend anybody, because what Thunderbolts do is coming up with a new theory, and you know, there's nothing wrong with that theory, but I do think a few things have left out. And you know, they don't really describe too much about what's going on with the sun in relation to gravity. And I think if you want to understand what's going on with our sun in relationship to the gravity and the plasma, and of course all these electrical effects, then you need to actually cover the actual foundations. So you can't go talking about, you know, plasma before you've actually covered why the plasma is there in the first place, and what has created the plasma in the first place. And you know what, I think if mainstream organisations such as those institutes over in I believe now China, that have invested, what is it, nearly £1 trillion in their nuclear fusion plants, if they was to take on board some outside ideas with regards to how other people interpret what's going on the surface of the sun, how it's generating its plasma, and therefore how the radiation is eventually ending up interacting with our atmosphere and our Earth, then I think that they could probably make some changes within that reactor that would probably get it to, you know, probably work a little bit more efficient. Because let's face it, at the moment, I think they have to turn off the power for about 4 or 5 cities, massive cities, in order to get this thing, you know, their nuclear fusion plant running for at least, I think it's about a minute they've had it running for now, 60 seconds. I know some of the countries with their fusion plants haven't had much success at all, and I think the problem is in the way in which they're misunderstanding the whole process. So, you know guys, what we're looking at is the model generally accepted. Okay, what most people think is that hydrogen is being converted into helium, and there's some neutrons being emitted as a byproduct of that reaction. I don't think it's the case. I'm going to give my ideas as to why that is. I'm going to cover a little bit of grounds on, you know, how we have gravity in the first place and what it's made of. So it's a little bit of a special upload, this one, covering this unique topic, because there is definitely something going on with our sun that is probably not widely accepted. And I'm not saying that my theory is 100% right, but it does make a lot of logical sense. So let's get on with it. Okay, so we're looking at a simple diagram of the moon and its force of gravity, 1.6 meters per second, the Earth and its gravity, 9.8 meters per second, and the sun and its gravity, 274 meters per second. Now, I think a child could work out this because it's simple, but a lot of this simple analogies just get completely overcomplicated, and as a result, I think it leads to a few mistakes even in science and some of these big organisations. Now, simply, these aren't to scale, but we know the moon is much smaller than the Earth, but more importantly, its surface area is much smaller than the Earth. We know that the Earth is much smaller than the Sun, and for the same reason the moon it's the surface area. Yet you can see the gravitational field, or the force, of the moon and the Earth compared to the Sun is way, way smaller. Now, it's simply because surface area is proportionate to gravity, or gravity is proportionate to surface area, and it's the electrical charge which attracts these things to our planets. I want to give you a good way of just practicing and having a little look at a little experiment that you can do. It won't cost you much. Buy some balloons, rub them on your jumper, and then get some tin foil, just small pieces, get some plastic sweet wrappers and cut them up into little bits, and then once you've got that little charge you've placed on the balloon, you can only put a small amount of electrical charge on a balloon because of its small surface area. But just watch what happens when you bring it in the vicinity of those two materials, that little bit of tin foil and that plastic sweet wrapper, because what they represent is the two most abundant materials in our universe. The first is a dielectric, which is the plastic sweet wrapper, a non-conductive, and the other one is a conductive material, the foil. And everything within our universe is made up, if you want to scale it down to the most simplest things, just a dielectric and a non-dielectric, either a conductive material or a non-conductive material. Now, we're talking about surface areas being proportionate to gravity, and what we're talking about is that these planets, at least our Earth and our Sun and our Moon, has a large surface area, and therefore an outside surface electrical field can be placed on it, and there's a greater electrical field that can be placed on the Sun's surface because of its immense size compared to Earth. And I'm going to draw the connection between the two, Earth and the Sun, because really our Earth is trying to be a better Sun than it is. And the reason for that is because it just doesn't have a large enough surface area to achieve what the Sun is doing with its surface area. And the reason for that is because there's a greater gravitational field on the Sun's surface. Let me just break down what's happening on the Sun, and then we'll quickly talk about how the Sun and the Earth are very much related with regards to what they're both doing. Only thing is that the Earth struggles to be a Sun for the fact it doesn't have the gravitation surface area. If it did, it would be doing exactly what the Sun is. But I want to just give you a little snippet here, guys. It does do it on a very small scale, at least over its poles. And we're going to get into the subject now of just plasma. So bear with me, I'll get the next slide up. So this is my model of the Sun, and I'll explain how it works, but just briefly I'll just say the reason why the fusion model of the Sun, converting hydrogen to helium and producing neutrons in a reaction, is no longer holding up, is because when scientists have studied the amount of neutrinos that are coming off the Sun, there's just simply not enough to explain the amount of reaction that's taking place in the process of fusion from hydrogen to helium. As well as it doesn't fit the convection model, and also there's another thing as well, another phenomenon that's taking place is that the photons that are leaving the photosphere are actually gradually accelerating the further away they get from the Sun. So there are a few problems with the standard model of how the Sun's working, so I'll just explain how my model works. And as you can see, we've got some photons here leaving the photosphere, which is an area above the Sun's surface. It's actually an area which is a lot hotter than the surface of the Sun, and I think my theory will explain why that is. The area in between the surface of the sun and the photosphere I've classified as the condensed electrical field caused by gravity. This is also the area in where the plasma is being formed, and again we've talked about the gravitational being proportion to the surface area. So if you've got a large surface area like the sun, you're going to have more gravitational field, and as a result of that you can have a lot more electrical charge, because gravity is just electrical charge on the surface of an area. And because the sun has such a large amount of it, it is actually compressing itself in this condensed electric field, and as a result of that it's producing its plasma. So the light that we see coming off the sun is only formed within these two regions, from the surface to the photosphere. And you know, it is understood that only from the photosphere, that is where the protons leave the gravitational force of the sun and then, you know, radiate on our surface of the earth. Now, earlier on I said the earth wants to be a better sun, and the reason for that is because the earth does have almost what you would classify as a photosphere. We call it the ionosphere. If the ionosphere was to compress more, it would produce the same effects, but the reason why it doesn't is because there isn't nowhere near the same amount of gravity as what the sun has. The only reason the sun is able to compress its ionosphere is because of its sheer size and gravity and surface area and electrical charge. Now the earth does do something very similar. It produces plasma over its poles where the magnetic regions are, but nowhere near to the level that the sun does. And you know, this is what I'm saying. If these institutes that are trying to build fusion reactions actually understood, you know, some basic principles, and you know, obviously the problem is here, guys, is that if you go to a university, you're going to learn the standard models. And you know, Nikola Tesla was actually one of the people that was warning people about this. You know, if you keep going to these schools and learning inaccuracies, then you're only going to reproduce inaccuracies, and your experiments are going to be terrible because they're based on errors. You know, errors in, errors out, and that's probably why they're not getting these reactors working. But guys, there is a little bit of light in the tunnel, because there is a way to concentrate gravity on small surface areas. And you know, we've had the technology for a long period of time. If you want to look into Townsend T. Brown and some of the experiments he was conducting for the United Air Force, I think it was back in the 40s or 50s, you're going to come across some of his electrogravitics experiments, and if you dig deep enough, you're going to come across the one where he charged the capacitor up to a point with, you know, a lot of power. It actually lifted the table that it was bolted down to and slammed into the ceiling of the hangar where he was conducting his experiments. And of course, from that point on, the Air Force classified most of his research. The point is this, is what Townsend Brown found is that by charging capacitors up, you actually lose their mass. They reduce in weight. And there is, as far as I'm concerned, there's the answer to anti-gravity, and you know, understanding how to build better fusion reactors in the future instead of using electromagnets to control the plasma within these reactors. The better way would be to artificially create a source of gravity that could create more than just its surface area, and the way you do that is exactly with capacitors. Capacitors store a charge over a rolled amount of material, and it's separated, the conductive material, by dielectric material. Isn't that a coincidence, guys? And it's rolled up very, very tightly, and then there's an outer cap placed on it, or a cup placed on it. And capacitors are able to store a lot of electrical charge within them, and then at a certain point of you know, it reaching maximum, it just releases the power. So you could charge up a capacitor with a source of 1 volts or 1 milliamp, and you know, then at the end of its, you know, when it's fully charged, the capacitor, it could release that in 400 volts and more milliamps. And this is exactly how gravity is actually working. It's using surface area, and the larger the surface area, the more charge you're able to place on it. The very two are closely linked, and this is what I was saying. You know, if you wanted to build in the future anti-gravitics material, then you know you've got to look at how we build CPUs, computers, and then bring that same technology in the line of building capacitors. And when you do that, you'll be able to store more charge in a smaller space, and you know you will eventually end up with a tile of a certain size that's able to store a surface area probably of about a square mile. And when you charge that up, you're going to get, you know, especially when you match the charge of the Earth's gravitational field, you're going to get an anti-gravitational lift or a propulsion. But more importantly, with regards to fusion, you can also create gravity that attracts the plasma. And you know, I think when you do that, you're going to make these fusion reactors much more efficient, and they're probably going to work a little bit more better. But the thing is, with the sun, one of the things that's puzzled scientists for a long period of time is that how can it keep producing, you know, this amount of photons when, you know, you don't really see what the fuel is apart from, you know, meteorite impacts going into the sun because of its gravity. Well, it's because it's not just attracting because of its size, you know, things that we can see. It's the stuff we can't see because we're not close enough to see it. It's actually attracting a lot more stuff, and you know, from the scale of interstellar gas and small particles to the size of, you know, large asteroids and meteorites. You know, this is what we're not seeing, and this is what keeps the sun producing the amount of photons that it does. But really, you know, what we thought was this was a fiery planet producing flames under a nuclear fusion process is not the case. It's simply able to compress its ionosphere, which is what we call the photosphere. And when it does that, and you put pressure on this electric field, you create a plasma. And it's the plasma which we see. And it's just the fact that these photons are able to leave the sun at a certain distance is that how exactly we managed to break gravity with a rocket. You know, we exceed the gravitational force, and you know, as a result of that, we break the Earth's gravitational pull. And that's how it's working. That's my view, or my theory on how the sun's actually working. You know, again, not many people talk about the actual effects of gravity. You will not be able to buy a book which tells you what gravity actually is. But with the experiments that I've conducted, and you know, those experiments work on both known materials, such as the widest materials in our universe, which are dielectrics and conductives. And if that is the case, then that must be the closest answer we've got to understanding, as far as I'm aware, what gravity is. And then when you understand what gravity is, you can apply it to things like the sun, the earth and the moon. And you know, it starts to make sense that surface area is regulating the actual force of gravity. But that doesn't mean that we can't cheat surface area by coiling it up into a little capacitor. As I've shown before, I mean, there's 300 odd videos on my channel, but I've shown before actually me pulling a capacitor apart and unraveling it so you can see what's in there. Basically, we've rolled up a surface area over a good 12 inches into an environment which is 1 centimetre or 1/8 of an inch. Guys, it really comes down to this. You can be taught the basics in a university, or you can exceed those basics by being taught by the universe itself. And I think Nikola Tesla would love that statement. I think he'd appreciate that somebody else was probably aware of an alternative source of knowledge. I think it's by appointment only for a few people. I mean, I don't know where half of these ideas I get come from, really. And I think he was in the same thought pattern. So guys, I hope you enjoyed this little deviation from our usual topic. We are not leaving our main topic by any chance. You know, the weekend, there's plenty of work for me to get on with, contacting a few people, and I'll do that over the weekend, and hopefully we can take a few more of these magnetometers to the post office and get them sent out. I'm sure that will be the case Monday. And the only other thing I've got to do is you know, build another web page for all the data, which will shortly be getting in from these magnetometers that are going around the world shortly. So I'm going to say what I usually do. Guys, if you want to support what we do on our observatory, on our channel, the links are down there. There's a PayPal link, and there's also, you know, you can support us on Patreon. I want to thank those guys that have been supporting us throughout our time on YouTube, at least, and most recently as well. Big thanks to all you guys, and it's only through you that has, you know, managed to get us where we are. So I'll say nothing more than what I usually do. Enjoy your weekend, and as always, bye for now.